Okay, so that part one of that video just cut off. I am sorry about that. But then the last step is to check your answer. So you plug 7 into your original equation. 7 minus 3 is 4. Then take the square root of 4, which is 2. 2 plus 2 is 4. So your answer checks out. Example 3. On this problem, we definitely have our square root isolated on one side, and in fact there's square roots isolated on both sides. So then your first step is simply to square both sides. Well, the square root and the square, those are inverse operations, so they cancel, so all we have is 3x minus 5 on the left side, and on the right side the same thing happens, so we have x minus 5. Okay, at that point you want to get the x's together, so we would need to subtract an x on each side. 2x minus 5 equals negative 5. Now we're trying to isolate the x. So this is a two-step equation. We need to add 5, which would undo the minus 5. And we get 2x equals 0. Now a lot of times students are like, oh, a 0, I don't know, that means no solution, right? No, 0 is just a number. No big deal. So you're going to then keep solving for the x by dividing by 2. And 0 divided by 2 is just 0. So your solution is 0. Plug it in. And this one gives you a little bit of an issue. When you plug in, so I'm doing my check right here. If I plug in 0 over here, I get 3 times 0 minus 5. And on the right side, I get 0 minus 5, both under the square roots. Well, on each of these, I get the square root of negative 5. So yeah, 0 gave me the same solution on both sides, but we can't take a square root of a negative answer. Square root of a negative number, that's an error in our calculator. It doesn't work. So we can't actually do this one. So there's no solution here that's going to give you a good answer. Okay, so we've got to check our answers here. All right, number 4. Again, in order to solve these problems, you need to isolate the square root on one side. So you want to make sure there's nothing on this side or one of the sides except for the square root and what's underneath it. We already have that in this problem, so we can go ahead and start by squaring both sides. The reason we do this is because a square root and a square cancel one another. So all we would have is y plus 2 on our left side. Now this right side is probably one of the most common mistakes in Algebra 1 and even into Algebra 2. What a lot of students want to do, which you cannot do, is they just want to put that square on everything and do something like that, like they're distributing the square. No, you can't do it. Don't do it. What you have to do instead is remember when something's squared, what that really means is you're multiplying it by itself twice. So you must write that out. And then we're going to have to do distributive. So y times y is y squared. Y times negative 4 is negative 4y. Negative 4 times y, negative 4y again. And negative 4 times negative 4 is positive 16. Okay, so we are combining our like terms on the right side. Negative 4y minus 4y is negative 8y. All right, so we're ready to solve now, but how do we do that? Well, I'm noticing this is a quadratic equation. It's to the second power. Yay, remember that from Unit 10, quadratic equations. We know 4 ways to solve: graphing, factoring, quadratic formula, completing the square. I will say, as you move on into geometry and algebra 2, when you see quadratic equations, most of the time you will be expected to be factoring them. Okay, so hopefully factoring is your favorite way, because that's what we're going to do here. In order to factor, we know we need to be equal to 0. So we're going to have to subtract negative y and negative 2. That's going to give you 0 over here. And on the right side, it would be y squared minus 9y plus 14. So a little review of factoring. There's 3 terms. That's AC method. Your AC is 14. So we need 2 numbers that multiply to 14 and add to negative 9. Pause the video for a second and go ahead and figure out what those numbers are. Okay, hopefully you got -7 and -2. Because there's a 1 right here and no other coefficient, you're allowed to take the shortcut. And the shortcut is, instead of replacing your middle term with those numbers, you just go straight into your parentheses. Okay, and you could always multiply this out and make sure it comes back out to our black equation, but it does. So then you set each factor equal to 0, and then we would add 7 to get y equals 7, and on this one add 2 to get y equals 2. Done, yay, answer. Move on to the next problem. Wait a minute, what did we not do? We did not check our answer. So the first answer to check is 7. So you need to be thinking about plugging this in to the original problem, just the black part. 7 plus 2 is 9. The square root of 9 is 3. On the right side, 7 minus 4 is 3. So that means our answer of 7, it checks. For your second answer, 2. 2 plus 2 is 4. The square root of 4 is 2. Okay, now ignore the 3's, right, because that was from our first solution. So now we're checking the second one. And again, that second solution was 2. 2 minus 4 is -2. Wait a minute. Does 2 equal -2? No, that answer didn't work. Did we do the problem wrong? No, we didn't. What this is called is, write it down, it's an extraneous solution. It is an apparent solution, apparent meaning it looks like it's going to be an answer, it appears to be an answer, but it doesn't actually work. So we did all of our work correctly, but when we checked our answer, that doesn't work. This will happen when you're solving these problems, so you have to check your answer. Did you hear me say that? You have to check your answer, because if you left y equals 2 as an answer, I will take off for that. You must cross it off and say, nope, that didn't count. Our only answer to this problem is 7. So be very careful. Circle the answers that work, cross off the answers that don't. Check every single one. Plug it back into your equation, see if it works. If it doesn't, either you did the problem wrong or it's an extraneous solution, like an extra answer. The reason that happens is in the step where you square both sides, think about like when you square a negative, it becomes positive. So because of that, sometimes you get this error. It does not always happen though. Sometimes it does, sometimes it doesn't. So you have to check your answers. All right, let's try one more together. In order to solve these equations, the first thing you want to do is get the radical and whatever's under it by itself. So that means we would need to begin this one by subtracting 8. That leaves us with the square root of 3y equals -6. Once you have your square root isolated, that is when you are allowed to square both sides. And we get 3y equals +36. Keep in mind, you need to square everything that includes the negative. A negative squared is a negative times a negative, which becomes positive. Finish solving by dividing by 3, and y equals 12. What else do you have to do? You have to check your answers. 3 times 12 is 36. The square root of 36 is 6. 6 plus 8 is 14. The right side is equal to 2. Does 14 equal 2? Absolutely not. Therefore, that does not work. And because that was our only solution and it didn't work, there is no solution. Okay? Here's a little hint. See this line right here, just the red part of it? See how it has a square root of some stuff equal to a negative number? This is illegal, right? Because you know if you're taking a square root, it has to be a positive number in here. And a square root of a positive number is always a positive number. So if you have the square root of some stuff equal to a negative number, you don't even have to do anything else. You can go straight to your answer and say no solution. Okay. What if our original problem was equal to -2? Would that be a no solution problem? Not necessarily, you would have to solve it and figure it out. The reason this isn't in this step is because you still have a plus 8. Okay, so the only time you can go and take this like quick, go straight to saying no solution is if the only thing on the left side is a square root. If there's anything else like a plus 8 or a times something, you have to keep solving. All right, you guys pause the video here and do these next 2 problems on your own. Pause the video. Do not keep watching until you have attempted the problems. Okay, let's check them out. On the first one, the first thing I did, because my radical was isolated, I squared both sides. That made the square root and the square cancel. And then I saw that it was a quadratic because I had n squared, so I needed to get it equal to 0 and factor. One of the biggest mistakes I've been seeing on the AC method, whatever your numbers are that you're picking that multiply to this, double check that they're really adding here to this number. This is a -1, but so many times I'm seeing students use +4 and -3. That would add to +1. We need it to be -1, so you have to use -4 and +3. So make sure you're checking, double checking that sign. I took the shortcut, went right into my parentheses, solved, got 2 solutions, but when I checked one of them, this one did not work. On the second one, started by subtracting 3, trying to isolate the radical, but I still had this negative sign. In order to get rid of that, you're either thinking of dividing by -1, multiplying by -1, but honestly, what I really think of it is just changing the sign on both sides. So this becomes positive radical, and this 9 becomes negative. But see how I have a square root of some stuff equal to a negative number? I know that, hey, that's going to be no solution. I don't even have to do any more work. Had you went through and worked this out and found a solution, when you go to plug it back in, it's not going to work there. So even if you don't see it here, you've got to check your answer once you get it, and then you'll see it does not work. All right, last section for 11.3. Get this packet done, and let's get done here.